Welcome, everybody. We're going to talk about what the slide says. We're going to talk about all the things that people don't tell you when writing a streaming app. This is Ted Malaska. Ted is a group technical architect at Blizzard, and I am a software engineer at Cloudera. The most common question for our presentations is where are the slides, and the answer to that question is on that slide, the first slide, right? And that's tiny.cloudera.com/streaming-app. I'm going to give you maybe 10 seconds to note that down or take a picture. And then if you so desire, type that link on your phone or on your computer and walk along. Yeah, so one more time, it's tiny.cloudera.com/streaming-app. All right. Another point of note, Ted and I are co-authors along with two other amazing people of this book called Hadoop Application Architectures, which talk about how do you architect applications that are sort of big data scale. And we have a book signing at 6:30 p.m. at Cloudera booth today. So if you'd like a copy, do want to line up early for that. All right, the agenda is just 5 things that no one tells you about writing a streaming app, and we're going to get right into it. The first one is about monitoring and managing. This is an example of a batch job, right? So you've got a bunch of data in HDFS or S3, then you've got some batch process, and then you write this data back to HDFS or S3. Pretty simple. Managing and monitoring in this batch job is pretty simple as well. You use something like cron or Uzi or Escoban or Luigi or a slew of other tools to orchestrate your thing. You may have some validation logic in your job. If the input directory is empty, then you spit out an email saying like, geez, we were expecting some input and it's empty. And you can also track the times that your batch jobs took, right? So if you have a daily job or an hourly job, it takes 3 minutes every day. One day it takes 13 minutes. You can track that and see like, oh, what happened, right? But in streaming job, there is nothing like that. You have this continuous stream of events coming out. There's a stream processing job, which then writes data to some storage system, right? This could be Cassandra, HBase or Kafka, your some other database. So orchestration here, which is a process of at least starting the job at periodic intervals, is somehow automatic, right? There's a concept of micro batch, and so that job is being started every micro batch interval. There is a long-running driver process. So ideally, your streaming job is never going down. It's always staying up. But some of the tools that we are using in our streaming jobs weren't really meant for long-running jobs. An example is if you're running Spark on Yarn, which is a resource manager, Yarn doesn't aggregate your logs from all these different machines that are running Spark executors until the job is over. And guess what? A streaming job is never over, so you never get the Yarn aggregation, right? The next one is checkpoints. So Spark uses this concept of checkpoints. I'm talking Spark 1.x line, and even legacy Spark streaming D streams like workloads use checkpoints. But checkpoints can't survive app or Spark workloads. So you've got an application, there was a bug, you fix the bug, and you want to upgrade that application, you got to clear out that checkpoints directory across upgrades, or it won't work. So the big questions still remain unanswered, right? The first one is management. The second one is monitoring. So what do we talk about in management? The first one is where do I run my driver? How do I restart my driver? How do I pause a job? And how do I resume it? For monitoring, it's like, how do I prevent a backlog? I have a certain amount of processing time, and I want to make sure all the time that the processing time on average is less than the batch interval time. So all my processing is taking place in the batch interval. And then you want to keep checks on the health of the long-running driver process. Is GC slowing it down? Is it going to go out of memory pretty soon? How do you track that? So most of what's going to follow now is based on our knowledge, and my knowledge is very much based on Yarn. It likely applies to other cluster managers as well, but what follows is mostly related to Yarn. So in Yarn, there's the first mode called client mode. Note on the left side box, there's a Spark driver, which is the blue box, and it's running inside the client application. So if you ran a job from your laptop, the client application is running on your laptop, and the driver is running on your laptop as well. In contrast, there's another mode called cluster mode. Note that the client is still your laptop, but the driver is not running on your laptop. It's actually running on a Yarn container inside this thing called the Spark application master. And so it's on a different node. So if you have a 50-node Spark cluster, it's one of those other 50 nodes, not on your laptop that launched the query or job from. So as it's very obvious, if you're running Yarn client mode and you're running a streaming app, if your client application dies, your driver dies. If your driver dies, your Spark application is dead, right? So you want to run your jobs on the cluster mode so that if your client dies, it's still okay. So that's the answer to our first question, 1A. The next one is, how do you restart the driver? Really, you don't want to go and manually restart the driver because bad stuff happens sometimes. You want to have an automatic restart. So in Yarn, at least, there are these two properties you set up. The first one is, how many times do you want to go restart the driver before you realize, oh, it's a legit problem? So that's the first property. And the second one is, because this job could be running for hours, days, months, and years, in theory, you have to provide a validity interval. So if you have one failure every hour, it's okay. But if you have 3 failures or more than 3 failures in an hour, that's not okay. So you have to legitimately kill the job. And so those are the two properties. The third one is how to pause a job. There isn't anything out of the box in Yarn, but if you're using Mesos, there's this program called Marathon, and you can use Marathon to suspend your app and later resume your app. Now we move on to monitoring. So we've got, oh, I need to move on quick. You've got monitoring. You've got a bunch of information on Spark UI. This is all the information that I'm showing here: records processed, min rate, bunch of percentiles. But really what you want is sometimes more than that, right? And for that, Spark has this pluggable drop wizard metrics library that you can plug into and use something like Graphite and Grafana. Those are really common to actually dashboard custom metrics that are accessible using this configurable metric system. So summary, some of this is afterthought. Monitoring and management wasn't really thought about. And it's possible based on the things we were talking about. This is all based on the dstreams mode of things. If you're using structured streaming, starting a very recent release, Spark 2.1, you can use this thing called Streaming Query Listener that provides you a bunch of monitoring stuff out of the box. There's references. If you got the link to the slides, you have these references as well. Okay, next problem, number 4, which is preventing data loss. So you figured out that, okay, I'm going to start my driver automatically in case of problems, but how do you make sure there's no data loss in between driver restarts? And I claim there is no data loss as long as you do things the right way. And what I'm going to talk now is, what does it mean to do things the right way? When you're looking at a streaming job, there are 3 ways you can consume data. The first one is a file source. You have a bunch of files on S3 or HDFS, and you want to pick them up as they come and do something with them. The second one is a receiver-based source. So you've got something like Flume or Kafka, for example. You've got a receiver processor that reads this data and then does something with it. And the third one is a distributed direct Kafka connector that Cody wrote. He just walked in. All right, so the first one is file sources. If you're using a file source, you can get no data loss by using checkpointing. Checkpointing is very simple. This is very, very simplistic. There is another method you have to set up when you for creating the context and provide that. But checkpointing checkpoints your metadata and your data. So metadata is what configuration was used, what incomplete batches and so on remain, and data is the lineage of your operations. So when you're doing stateful transformations, you really need to do data checkpointing so you can trim the lineage that you have to store. And Spark checkpointing has both data and metadata that's being checkpointed. But there's gotchas, right? The first one is these don't work across app or Spark upgrades. And that means that you have to clear out the checkpointing directory or change checkpointing directory every time you upgrade your app or Spark. So Ted had a small little rant about reading files in Spark streaming, and I'm going to let him go on this rant.
Yeah, so if you're ever involved in any of our PowerPoint discussions, me and Mark debate like crazy on everything. But this is one of the ones that I wanted to bitch about. So if you're reading off of files, I don't like to use Spark streaming. I like to use just Spark with a loop. And the difference is there I can do micro batching, because in a lot of ways that's what Spark streaming is. But then I get full control of the driver. So one particular use case that I really like is I like to look at all the files I'm about to process. I put them into a processing folder. And then, like, let's say I want to compress them as part of my ETL process. I can look at the size of the files in my processing folder, and I can make an estimate on how many partitions I want on the write. These are things that aren't as easy to do or might even be impossible to do with Spark streaming. But that's just my thing. So if you're reading from something that, like, not Kafka, I wouldn't use a Spark stream for that.
Fair enough. All right, so the next category of sources is receiver-based sources. In this, you have a separate executor or small set of executors whose sole purpose in life is to get data from the input data streams. And then they produce batches of data that is then used by other executors to process and do whatever they want to do. In receiver-based sources, if you want to prevent data loss, you have to do two things. You have to enable checkpointing for reasons we talked about previously in the file sources, but you also have to enable a write-ahead log. And by the way, the default value for the write-ahead log is disabled. So if data loss or preventing data loss is important to you, I hope it is, then you have to enable it. And why do you need a wall? The reason is without a write-ahead log, a failure in the middle of the operation can lead to data loss because there are some blocks that are still not replicated that you may lose handle to if there's a crash. And so with the wall, the data is written to a durable storage, usually HDFS or S3, and then it's acknowledged to the source. And so the source has no knowledge unless you have actually persisted to durable storage. Wall gotchas, it makes a copy of all your data on disk, right? For example, if you're using HDFS by default has a replication factor of 3. So in fact, it's making 3 copies of the data on your distributed storage. But then you may ask, what if I'm using Kafka? Because Kafka on its own also stores data durably, and it actually has a replication involvement there too. So now you're storing 2 copies of data, one in Kafka and one in the write-ahead log. And you may ask, why store another copy in the write-ahead log? Which brings us to the third way of reading data, which is this direct connector that I alluded to earlier. There is no need for a write-ahead log with the direct connector. This is a diagram of what the architecture would look like if you were reading data from Kafka using a receiver. So there is that green box at the bottom called the receiver, which is reading data from Kafka using a high-level API and stores the offsets in Zookeeper, and then persists the data in HDFS or S3 as a write-ahead log. But without the write-ahead log, you have each executor, the driver is tracking the offsets, each executor is reaching out to Kafka brokers and reading data from Kafka topic partitions. So why is no wall required? Because data is stored in Kafka directly and it can be recovered from there. There are some gotchas for direct connector though. So if your driver goes down, you still need to figure out what were the last offsets that you read and processed. So that means you have to actually store your offsets somewhere. A very common thing that people like to do is store the offsets in checkpoints. And I am not a big fan of that. And that's primarily because checkpoints are not recoverable across states, across upgrades. So what you have to do is track the offsets yourself, and you can do them in Zookeeper, HDFS, or other databases where you may be outputting your processing to. For accuracy, processing is best idempotent, or you need to store the offsets in the same data store and use transactions when you're storing the result as well as the offsets. So data loss is preventable. You can do that based on the sources we talked about in structured streaming. State is stored in memory backed by a write-ahead log. And you may have learned about this in TD's talk as well. And here are some references, and I'm going to pass this on to Ted to talk about the third thing no one tells you about.
Okay, do you really need to use Spark Streaming? So what do you use Spark Streaming for? Everything, right? So you use it for querying, you use it for aggregation, you use it for real-time machine learning, and this is probably everything you've heard at this conference. It solves everything. It solves making cereal and eggs and bacon and everything. But seriously, let's talk, what are your use cases, right? So these are the type of things that I can imagine you would use streaming for, right? You would do atomic enrichment, you would do notifications, you would do joining potentially, partitioning for different reasons, ingestion into something else, right? Counting, incremental machine learning, and progressive analytics, right? So I'm going to walk through each one of these, and I'm going to ask a serious question. Do you need Spark Streaming? And hopefully Databricks will invite me back next year to keep talking. So atomic enrichment. This is where you have a record and you just want to convert it, right? Like let's say if your data coming in is a protobuf and you want to convert it so it ends up in Parquet. Do you need Spark Streaming? Not really. Could you use Spark Streaming? You could. But it's now a huge Yarn application that's running, doing micro batches for the sake of doing a transformation, which could have been done with like a Kafka Connect or Flume or just a JVM, right? So do you need Spark Streaming for this? I would question, right? Notifications. So notifications, even with the new Dazzler thing, right? What's it called? Dazzle thing today, where they get their their latency times lower and lower. Do you need Spark Streaming for notifications? So if you're just reading something off a pipe like Kafka and then doing an alert based on the atomic information and maybe some cached information that's been broadcast out, do you need Spark Streaming? And the reality is you could solve it with almost anything, right? Spark Streaming would probably be higher latency than typical other solutions that could do it. So again, it's probably you don't need Spark Streaming. This is just an idea of, the partitioned metadata would be sent to each node, so you could do like local lookups and stuff like that. Or you could do a fetch to an external system like Cassandra or HBase or something like that if the data was too big to fit on a node. So joining. So this is one of those ones I'm like, do you really do this? How many people do big joins in streaming?
I'd like my boss to think so.
So I've yet to see this use case in reality. And really, even when I saw it once, I asked, what is he doing? And there was another way of doing it. So are you doing big joins in streaming? You're probably not. Are you doing broadcast joins? Yes, probably. So dimensional lookups and stuff like that. We already talked about that could be solved with memory being split across the different instances and solved with anything. Streaming joins, I've heard of some people talk about these. But again, normally they're just time windowing things, and time windowing things could be something you do with streaming. So this one's a maybe. I would have to hear your use case, but in a lot of chances it might not be a real use case. I forgot to put a diagram in.
Oops.
So the other one is fanning in and fanning out. Fanning in and fanning out is really important. Like fanning in is this idea if you have millions of clients and you eventually want to fan into one system, you may want a whole bunch of Kafkas or a whole bunch of message systems and then aggregate that down to a smaller number of partitions so you can feed that into your storage platforms. Do you need Spark Streaming for fanning in and fanning out? You don't. You could solve that all with Kafka, really. What about shuffling on keys for partitioning on keys? Again, you can do that with Kafka. Kafka out of the box has partitioning, right? If you want. All right. And side note, though, if you're ever doing partitioning in any type of streaming, be very mindful of skew and consider salting your keys. So ingestion. Do you need Spark Streaming to ingest? And in reality, Spark Streaming might not even be the right tool for ingestion because you lack some tools like how many records are in a batch, right? So writing to HDFS and block stores, it does make a convenient thing to write parquets, but you don't get the full control that you would get with something like a Kafka connector or Flume. And again, this isn't a shuffle, it's just writing, right? So there is some kind of benefits maybe could be argued for file systems, but for NoSQLs and Lucines, and that's Solr and Elasticsearch, and Kafkas, it doesn't really matter. The microbatching doesn't really give you anything. So again, that could be anything, right? Okay, now we start getting into a real use case for Spark Streaming. So if you need to do counting and it needs to be accurate, there could be argued that Spark Streaming is a good solution. But again, what use cases? And I'm trying to go fast because I'm in a couple of minutes. If you're trying to aggregate millions of clients down to something reasonable, like millions of servers or users and trying to aggregate those down to a region, then it's really something you want to do. If you're doing something like what is the stats or metrics on given servers or something like that, and it's underneath maybe 10,000, a time series database is going to do you just as well as Spark Streaming. So counting is a great Spark Streaming use case, but it's only in extreme measures that I would recommend really using it. Machine learning, I think, is a great situation for Spark Streaming. I think Spark Streaming is better than almost anything else for this, where you can do progressive machine learning in real time or near real time. And the other one, this one I have never really done, but this one you'll hear, I'm running SQL on a stream. How many people do that and really get value out of that? I know it sounds sexy, but like, is it really valuable? All right, I didn't think so. So is this amazing? Yes, amazing, but really are you supposed to do it? I don't know. If you have this use case, I would really like to know why you can't use a Cassandra or Kudu or an Elasticsearch or a time series database to meet your needs. Why are you interrupting your stream to run your analytical workloads? And if you do argue that you need to do that, I would really like to hear your multi-tenant story. Okay, and then windows and aggregations I think is a great use case in the end. I think that's it for that one. I'm a little bit behind. So exactly once notation, no duplicating records, perfect counting, is it possible? You'll hear everyone from Spark Streaming to Flink to any streaming engine will tell you can do perfect counting, right? And I'm here to tell you, well, you kind of can. And some people will say Lambda. If anybody says Lambda today, they're like a decade old in their literature. Lambda does not need to happen anymore. Lambda was a principle of the fact that at the time, Storm did not keep its own state, and the state was in the storage mechanism, and then the transaction of the storage mechanism incrementing was separate than the transaction of committing the record back to the queue. And because of this, you had this use case. You could increment, you could have a failure, and then you increment again. So you get a double count. And this is why Lambda kind of existed, right? But Lambda is complicated. Lambda is ugly. So Spark Streaming came along, and because it can have state within itself, and now many engines have copied this mechanism, because it has state that's within itself, when it has failure, it goes back to the previous state of the previous batch so that the counting is accurate and you don't get a double count. And in this scenario, what you're doing is you're putting to your NoSQL solution, you're not incrementing. And through this, you can't double count, right? So Spark Streaming by itself and a NoSQL solution, yes, you can do perfect counting in that, but there's still some holes in it. Spark Streaming is just one tiny little box in your entire architecture. All that other stuff, shit can happen, right? So yes, you get perfect counting, but if your source sended twice, well, you're out of luck. If your sync dropped messages, well, you're out of luck. If your sync submitted twice to Kafka, you're out of luck. If your consumer read messages more than once, you're out of luck. So there's a lot of places where you can get screwed on this. There are patterns to protect yourself. You can put sequences with every producer of data. So what you would have to do then is essentially partition based on the sequences and make sure that every single consumer is sending things in the right order and stuff like that. There's other things like out-of-bound messages, and I know Spark has now said that they do out-of-time event messages, but even that is within a window. And if your messages are really out-of-bound, the only option you have is to either go to a storage mechanism to retrieve the previous value, and that becomes even more complicated because now you need to remember the offsets in Kafka. So can you get perfect counting? Yes, in theory you can. Don't promise your boss that. And I mean, if this is a bank application that is monies and dollars, please let me know so I can switch my bank. But you can do very, very close. You can get extremely close. But there are so many places for failure. And I think I went through most of this. Okay, graceful shutdown.
You start.
Oh, I start on this one. Okay, this is the first time we've done this presentation. Can you define graceful shutdown? We want to shut down Spark Streaming in such a way where everything is in a good state. We know where our offsets are. We're not halfway in anything, right? And there's a couple ways to do this. In the end, we want to call this method, right? We want to call this stop, and we want to do graceful shutdown. And if you look into the code, this is what it's doing. Default, it'll wait 10 seconds. But if you say graceful shutdown, it'll wait until it's done. So it's very possible when you say stop, even without graceful, that you'll stop gracefully. But just to really get it done right, this is how you do it. And again, you can see it waits hours instead of seconds, right? But it's still not a guarantee, but it's a pretty good hit that you'll be fine. Now, you can call this from the command line and shut it down from the command line. You could also put in like a file on S3 or HDFS. Is this yours?
So that's my favorite way to do it, is to have a marker file, and that file is usually on HDFS, for example, and that exists, and the app is just constantly, there's a thread on the app that's just checking for the existence of the file. And when you want to kill that or stop that app, you take that file out, and the periodic thread in your Spark driver then sees that that file has disappeared and then gracefully shuts down your application. And again, by our definition, you want to make sure that your offsets are stored before you shut down. And like we talked in the previous section, you want to store and manage the storing of your offsets yourself, and you can store them in Zookeeper, HDFS, HBase, or your database of your choice. When you want to restart your app, you always go look at the managed offsets that you were storing somewhere and read those offsets and send them in your direct Kafka connector, for example, to start from those offsets. So summary, you can use the command line that Ted talked about earlier, or you can use the background thread with a marker file. So that's all from us. There are these 5 things one more time that we talked about. The first one was how do you manage and monitor your jobs? The second one, I guess the fourth one, was how do you prevent data loss? Then we talked about, do I really need to use Spark Streaming? How do I go about achieving exactly once, effectively once semantics when I'm using Spark Streaming? And the last one was, how do I gracefully shut down your app? One more time, the book signing's at Cloudera booth at 6:30, and that's all from us. The slides are right here. This is Ted Malaska. I'm Mark Grover. Thank you very much for coming.
We have 4 minutes for questions.
Yeah, we've got 4 minutes for
Feel
questions.
free to tell me that I'm dead wrong on streaming. It's totally okay.
You're dead wrong.
I am biased.
And if you guys have any questions, can you please walk up to the microphone so that people can hear that are watching this streaming?
So I have a question about how do you see use Spark Streaming as a way to deploy machine learning models? Because the way I see it, you can have micro batch of data, right, fed into Spark, where you already have a trained model, and you can make predictions on this micro batch of data in, say, 1 second or 500 milliseconds, right? And the outcome you can feed back to, say, Kafka, and it goes back to like the front. So how do you see like the use Spark for this use case, Spark Streaming?
So what you're talking about is model execution, which could be done at notification or something like that. Model execution doesn't actually require Spark at all. So even if you're using a Spark model, right? A Spark model can be executed outside of Spark, right? A Spark model is just code that executes on a vertex array or whatever, and then it gives you a result. That can run in a regular JVM, anything, right? So, and it runs very fast, low milliseconds. When I talked about progressive machine learning, I was talking about, let's say if you wanted to do k-means in real time. So the centroids would be moving progressively throughout the day. Or you could be generating new models that could then be persisted, sent somewhere else that is doing the validations, right? So that's something that you would use Spark Streaming for. Spark Streaming can be used for the method you talked about, but it's not required to do what you talked about.
I see. So you actually said something I'm not aware of. So you are saying that with a trained Spark model, you can just directly run that in JVM and make predictions, say, in a few milliseconds?
Yeah, it's beautiful. So once you make a model, like once you do that like fit thing and it generates a model pipeline object, you can serialize that and you can write that to disk. Another JVM can pick that up and then start doing work with it.
Cool, thank you.
Yeah, because it's just an atomic operation. Think about random forest, right? Random forest is a whole bunch of like if else, like greater than this, less than this. It doesn't need a cluster of CPU to say, based on this vertex array, what's my output of random forest?
Yeah, exactly. I'm just thinking in terms of like the interface, right? You like, for example, use PMML as an interface of like the model you build and the Java code writing on top of that, right? So I don't know like how to like take a build Spark model. I just store it on the disk and just read it in.
Yeah, I think there's just a transform method. You put in a data set and it pops it out.
Can we take one more question?
Hi, just a question on logging, so real-time logging, extracting logs. What's your notion of best practice, Logstash, Kibana, Elastic, Solar?
Yeah, so the question was about logging. Like I mentioned in the slides, Yarn, or it really depends on your cluster manager, but Yarn doesn't do aggregation. So what I've seen people do is that ELK stack, the few names that you mentioned, Elasticsearch in Kibana, to then aggregate the logs as they're being generated on the Yarn node managers, for example. and be able to search them through Elasticsearch down the road, even though your streaming job is still running and Yarn hasn't got.
Is that what you were talking about?
Yes.
Yeah. So
Eventually, Yarn is working towards doing aggregations as things go along instead of waiting for the application to actually finish, because that doesn't really apply to long-running apps, but it's not there yet. So people are using something like the ELK stack. Good.
yeah.
Yeah.
And yeah, Elasticsearch is expensive, so be very careful with your time to live, or Solar in that matter. Any kind of Lucene, they're wonderful, but wonderful comes at a price.
What do you mean expensive?
Oh, if you have no money problems, then you're in a great place. But in terms of their storage density is not as good as traditional other systems, and they're CPU hogs as well. They're CPU hogs and they're storage hogs.
But in this case, a server
In this case,
right?
it's live logs. You know, they're a perishable product.
Yes, as long as you set your time to live well,
Yeah.
then you'll be fine.
Thanks.
Okay, we're getting asked to get out of here. So thank you everyone for coming, and we'll see you around.